No, that is what we talk about the reversible. What do you mean by reversible? Can you please tell me?
Reversible means whether so if you have Na plus Cl becoming NaCl, reversible would basically be whether that NaCl can become Na plus Cl again.
Hmm. See, okay, that is what you answered. That is reversible. Reversible. NaCl is not possible. For NaCl, we cannot say. That is, you keep in mind,
Hmm.
because it is the strong electrolyte. Se is strong electrolyte. So it is going to be 100%. What is that? Is Na plus and 100% Cl minus. This is again going to be 100% and 100%. Okay. So this is not going to reverse back because it is going to 100% dissociate, which is weak electrolyte dissociate. Okay, so reversible reaction, if you are talking about reversible reaction, so what is the reversible reaction? The reaction which proceeds in both direction, that is forward. If you are talking about, that is forward and backward, that is forward and backward. This is what the condition. Forward and backward, the reaction which proceed in both direction, that is forward and backward. In bracket, I am talking about weak electrolyte. That you need to keep in mind. Weak electrolyte or some other things also you can say. Okay, but it should not be very much strong. If any strong means that is 100% dissociation, that is not going to be good. Now what we are going to say here, suppose I am having the N2 plus 3H2, right? This is the Haber process, and it is giving 2NH3, right? So they are saying this is the amount of the N2 and 3H2 combine to give the forward, this direction forward. Okay, so the same
Hmm.
amount of this NH3, same amount, this is going to split into this, so this is going to be backward. Okay, it means
Okay.
this reaction is also running in the forward direction and also running in the backward direction at certain condition. So this type of reaction is known as, what we can say, that is reversible reaction. Are you be able to understand?
Hmm. Yeah.
Okay, so this is condition. If you are talking about, what about the irreversible reaction?
So that would be one that is only possible in forward and not in backward.
Hmm.
Oh, sorry,
So,
reverse.
this takes place only in one direction, okay, one direction. The example you told me, that is like, that is NaCl is there. NaCl is very much strong electrolyte, so 100% it is going to give Na plus and Cl minus. If suppose you are having the H2SO4, it is also going to give, that is H plus 100%, and that is also HSO4 minus, provided
Hmm.
the water is lesser in amount. Okay, if the water is too much in quantity, so maybe the condition may be that it can be little bit reversible. Otherwise it is going to be always irreversible, because both are the strong means it is going to split into the, what it is going to 100% into the product. So this is what the condition of reversible. So let's try to move in another point. See, if you apply the equilibrium, okay, so firstly you try to the types of equilibrium, better types of equilibrium. This is also there in your AP curriculum, types of equilibrium. So on the basis of phase, on the basis of phase, on the basis of phase, you must have read out this one. Can you tell me, on the basis of phase, how many types are there?
Types of equilibrium.
Hmm.
For homogeneous and heterogeneous, two types.
Homogeneous and heterogeneous.
Heterogeneous.
Heterogeneous. If you talk about the homogeneous, okay, so what is the homogeneous?
It is one that remains constant, like it's all aqueous solution throughout. Like it's
Mhm.
completely well mixed together.
Yeah, you are saying that is the solution. You went into
Oh,
the
sorry, solution.
you entered into solution. That's okay. That is great things that you are till now connected with the topics. Okay, because they are the almost similar terms are there, right?
Mhm,
But when you talk about that is homo, what we are going to write that is homo. You see the homo, meaning of
mhm.
homo. Homo means same.
Same.
Homo means same. Now on the basis of phase. So what will be the same phase of all species? Of all species. All species means that is all species that is reactant and product.
Mhm,
Reactant and product. Okay. And when you talk about the another things, I am talking about hetero. So hetero, you already told you that is that this is going to be different phase. You know what will that is different phase because this is on the basis of phase. So that is going to be different phase of what that is reactant and product. Okay, reactants and product. Anyone is getting different, that is not going to be the homogeneous. So let's try to understand this one by one. CaCO3, calcium carbonate, that is also known as limestone. Okay, marble, limestone.
mhm,
So this is going to be in the solid form. When it is getting split in the reversible process, it is going to be give that is CaO solid plus CO2 gas. It is going to CO2 gas. Now what we are going to see here is two are the solid, one is gas. Two are the solid, one is gas. So this is getting reactant is solid, one product is solid, another is gas. So that is the heterogeneous. Yes, yeah, no?
mhm. Yes.
Okay, this is going to be heterogeneous. Similarly, if I am having that is NH4Cl, okay. So if I am heating this one, so it is going to give NH3 plus it is going to give HCl. So this is going to be gas. This is going to be gas, but this is the solid salt. So this is also one is solid, two is gas. So again, it is going to be heterogeneous. Yes, yeah, no?
Yes.
Okay. Now come for this side. Suppose I am taking that is H2 plus I2. Okay. This is the hydrogen is gas, iodine is gas. So it is giving that is 2Hi. This is again gas. So this is gas, gas, gas. All are same phase. So this is going to be what? Homogeneous. This is going to be homogeneous. H,
Mhm,
the condition is as all are in same phase. Same phase. Okay, so this is going to be gas. If I am taking H2 plus, I know 3H2 plus N2, the same equation, it is going to give 2NH3. So you know ammonia is the gas, nitrogen is gas, hydrogen is gas. So this is example of what this is going to be homogeneous equilibrium. Yes, yeah, no?
mhm.
Hmm. So this is what the point of about. Okay, so I'm erasing this one and moving to the another page. Okay. Now the next point, what is there? Sorry, yeah. The next point is their equilibrium constant. According to
Hello.
yeah, a little bit it was stucking. Equilibrium
Okay.
constant. Okay.
Mhm,
Of equilibrium constant in your book, it is given K only. Okay. So here we study Kc. C
mhm.
for concentration. That you keep in mind. If you are writing or not writing, that is no problem. C for
Yeah.
concentration. Concentration. So C for concentration. So equilibrium constant we have to study. So if you talk about the equilibrium constant, how to study the equilibrium constant? So they are saying it is it is ratio of molar concentration of molar concentration. They are saying molar concentration of reactant, molar concentration of reactants and molar concentration of product, molar concentration of product, molar concentration of product raised to power. They are saying raised to power coefficient, raised to power coefficient. This is raised to power
Mhm,
coefficient. So this is what the condition. It is the ratio of molar concentration of reactant and molar concentration of product raised to power coefficient, okay, at equilibrium. At equilibrium. So now let us try to write down the expression. Suppose we are having A mole of A plus B mole of B. It is going to be C mole of C plus D mole of D, right? So if you are writing that is Kc, because it is the molar concentration. Okay. One point you need to keep in mind, molar concentration is the new term. Molar concentration. Molar concentration means moles per liter. Moles per liter. This is also, if you are writing moles per liter, one more thing you can write. That is what molarity. You study already in the solution, molarity. Or you can write that is active mass. Active mass is old time we were using, that is active mass. Nowadays we are using the molar concentration. These all together, these all together is represented by square bracket. This is expression is x square bracket. So see how I am writing. So product of molar concentration, it is ratio of molar concentration of reactant and product. So you little bit we need to change it out. Product and reactant. It's not the correct one. Product will be on the top and reactant will be on the bottom. Okay. It is the ratio of molar concentration of product and molar concentration of what are the product. C is there, C power C, and that is what, that is we have to product, we have to take the product. So this is going to be D power D or divided by A power A and B power B. B power B. So this is the equilibrium concentration. Okay. Between these two, what is there? Nothing is there, means this is the product. You can define it is the ratio of product of, you can write that is here, the one term can be increase also, ratio of product of ratio of product of molar concentration of product and product of, we can write that is product of molar concentration of reactant raised to power coefficient at equilibrium. So Kc is equal to C power C, D power D upon A power A, B power B. So this is equilibrium constant. Can you be able to understand?
Yeah.
Good. So here you see the another term, what we can write here. Question is there. Write expression for Kc. Write expression for Kc. Okay. For following reaction. Rxn, following reaction. So they are saying that is the first one. You go for this one. N2 plus, similar question I am giving, N2 plus 3H2, it is giving that is 2NH3. This is the gas, this is the gas, this is the gas. Okay. And if suppose I am writing that is B, H2, 1 by 2 H2 gas plus 1 by 2 I2 gas, it is going to give that is HI gas. This is the balanced one. Okay. They're asking. Okay. And C number. Similarly, you can write that is NH4CN. NH4CN, this is the solid. So this is converting into HCN. This is the going to be the gas. And here is also going to be give that is NH3. This is again going to gas. This is the solid. D number PCl5. This is the solid. PCl5 solid. It is converting into PCl3. They're going to be liquid plus Cl2. It is going to be gas. Okay. So before studying this point, I want to make it clear one another point. What is the point? Note. This is the very important. Okay. For whole chapter, it's quite very important. See, in the expression of equilibrium constant, here they are saying in the expression of equilibrium constant. Now, if I will define one more term. Here we are writing Kc or Kp. Kp I will define just after this. Kc in the expression of equilibrium constant Kc. Okay. They are saying or Kp, the solids and liquid, they are saying the solids and liquids are not taken. or not taken, as their concentration, as their concentration, as their concentration do not change. Okay. So what other point? Only gas and aqueous solution taken.
Right.
Aqueous solution taken. Gas and aqueous combination. Okay. So these two things are taken. The rest of things are we are not going to take. Yes or no? Getting? Okay. So let's try to write. See here, the all are the gas. In the first one, A number one is the all are the gas. So if you are writing Kc, right? Kc. So what you can write, that is NH3. This is going to be gas. Power we are going to write, that is 2 divided by what we are going to get, N2. This is going to be gas. This is the this one. The H2, it is going to be gas. This is the power to be 3. Yes or no?
Yes.
Now B number, you see. B number, if you are writing Kc, this is again going to be the gas, but here coefficient has been changed. So that is Hi. This is going to be gas. Here is the power will be no power because here is no coefficient. Here if you are writing, that is H2, this is the gas. Power if you are writing, that is 1/2, and I2, this is going to be gas, and if you are writing power, that is going to be half. If you are talking about C, Kc, can you please tell me the Kc value for this one, C?
So this will be 1 over, HCN to the power
HC.
of 1
Yes.
multiplied by NH3,
Hmm.
and that is it.
Okay, that is good. Today the system is getting hacked. I don't know why. Hanging too much. Wait a moment, please. Yeah, it's working now. So this is the NH3 gas. Okay. Now we are leaving out that even solid one is we are leaving out. What about the D1? D1, if you are going, that is Kc is equal to
So
what is going to be?
D1 is just going to be concentration of Cl2 because PCl3 is a liquid and not aqueous.
So this is the liquid is there, so we have to take lift out this solid also we have to lift. So Kc is equal to, that is going to be Cl2. So this is our required answer. Yes or no?
Yes.
Okay. So please make a note of it.
Yeah.
Yeah.
All right. Yeah, I made a note.
Okay, thank you. So let's have one problem on it. So you please try to solve that problem. Okay, I'm giving you the problem. I'm writing here. The very easy problem is there. N2 and Cl2 produce, they are saying Cl2 produce NCl3. Okay, NCl3. The equilibrium concentration they have given. The equilibrium concentration. What are the equilibrium concentration? Equilibrium concentration. Equilibrium concentration, if you talk about this one, how much is there? Equilibrium concentration of each gas they are sucking. Equilibrium concentration of each gas are, this is what into they are talking about. Active mass they have given 0.15, and they are talking about Cl2, how much they are talking about 0.25, and NCl3 they have also given for this one 0.50, and these all are in the molar. Molar means mole per liter. So they are asking, that is find Kc, find Kc. Okay, so they have given the option, you please try to calculate. Please try to calculate. So A number option is there 102.7, B number that is 100.7, D number they are saying 109.7, Okay, and D numbered here they are saying 90. Okay, K is unitless. Kc is unitless. That you have to keep in mind. Unitless. Because wherever the no K is unitless, and one more things we have studied, mole fraction is also unitless. That I told you, mole fraction is also unitless. So what you can do here, see, we are having the N2, then we are having the Cl2, then it is giving what NCl3. You can make it balance. The nitrogen is 2, so we can multiply by 2. Now chlorine you can see 3 2 is 6 here is 2. So we can multiply by 3. So this is going to be gas. This is also existing in the gas. This is also exists in the gas. So Kc, if you are writing Kc, so how can we write? That is NCl3, it is going to be gas over 2. Okay, and here is N2, this is also going to be gas. This is this one, and Cl2, this is again going to be gas. Its power will be what? It is 3. Now, see student, what we can do. NCl3 value they have given how much? 0.5, and we can do the square of it. Then N2 also they have given 0.15, I think 0.15, and divided by another things is 0.5, and it is Q. It is going to be Q. Now let's try to solve. If you are talking about this one, 0.5, and no, we wrote the correct one. No, Cl2 is not this one. 0.25 is this.
25 cubed.
Yeah, 25 cube. Now solve it na. Solve it. Sorry.
Yeah. So this is going to be this is 0.5 square divided by 0.15. I got 106.66.
Is it?
0.1. Yeah.
No, but that is not coming. They are giving, it is going 102.7 approx, they are saying.
0.5 squared divided by 0.15 multiplied by 0.25 cubed. Yeah. Okay, I'll check with my calculator later. It might be my calculator.
Okay. You try to, this is the option they have given, the one number option. They have given A. Okay. They have given the option number A is the correct option. The value they have written everywhere, they are saying that is approx. Means that is 102 is that should come anyhow. Okay, it will come. The process we understood, that is what the important things. Now, can I change the slide?
Yeah.
Okay. Now the question they are saying, equilibrium constant in terms of, for gaseous system, gaseous system, it means what? Gaseous system means when partial pressure is given, when they are saying partial pressure is given, partial pressure is given. So when the partial pressure is given, then they are asking that is how we will be able to calculate the equilibrium constant. Okay, that we try to understand. So if we do that calculation, they are saying that is here, that is it is represented by Kp. P for, if you are defining P for partial pressure, this is going to be partial pressure. Okay, partial pressure. Now, what we will be able to do in this condition, if you write in the term of, suppose I am taking this one, the same equation, A mole of A plus B mole of B, it is going to give the C mole of C plus D mole of D. So what we can write, if you are writing Kp, so that is we have to write Pc, partial pressure of C and power going to be C. Then again partial pressure of D and power going to be small d. Okay, the coefficient has to be power. Then it is going to be PA and power has to go small a, and PB and power has to go, that is small b. Are you be able to understand this one? Yes, no?
Yeah.
Okay. So this is in the terms of the partial pressure. When partial pressure is there, so that is we have to write PC power C, PD power D. If you are writing that is A, B, C, and D, so they are going to be coefficient. And if you are talking about that is another term PA, comma PB, comma PC, comma PD. So they are the partial pressure of each component. Partial pressure of individual gas. Okay. Is it okay?
Yeah.
Okay. So let's try to solve one problem based on it. Oh, it's got deleted. It's got deleted completely. Okay. I don't know you wrote or not the last slide.
I did.
Okay, good, good. So here I'm writing one more problem. They are saying SO2 and O2 gas produce SO3 at equilibrium. They are saying at equilibrium. What they have given at equilibrium, partial pressure at equilibrium, partial pressure of okay, each gas, partial pressure of each gas are, they are saying 0.10, they are saying 0.010, 0.30, 0.45 atm respectively. Respectively means the first one is SO2, second one is O2, and third one is O3. Calculate Kp. Calculate Kp. They are talking about calculate Kp for formation of SO3. For formation of SO3. Formation of SO3. A number option they have given 67.5. B number option they are saying 107.5. B number option 208.5, and D number option they are saying 109.5. These are the options. So what we can do, that is SO2 is there. This is going to be gas. Sulfur dioxide is a gas. O2 is a gas. If you change this one, this is going to be give SO3. That is also going to be gas. If you balance it out, so oxygen is here 3, here is 2 to 4. So we can multiply by these two. So 3 to just 6, sulfur is 2. You can multiply by these two. So 2 to just 4 to 6. Everything is balanced, everything is gas. So if you are writing Kp, how can you write? So PSO3 power we will write what? Power we have to write 2 divided by PSO2, it is again going to be power will be 2, and PO2, it is going to be power will be going to be 1. Yes, yeah, no?
Yeah.
Okay. So SO3, you can see these things where I'm cancelling out. SO3 value is this one, O2 is there, this one, and SO3 is this one, because respectively what they use, so they are in the similar ratio. Okay, so I am writing SO3. So SO3 means 0.45, this is going to be square, divided by, if I am writing 0.10 SO2, this is going to square, and the another is there O2 is 0.30, this is there. So what we can do here, we can multiply this one. Let's try to multiply this one. So upper one is coming
67.5.
67.5. Thank you, thank you. This is coming now. So this is the 67.5. Okay, so Kp you got. So this way we calculate, that is Kp and Kc problem. Okay, okay. Next one more relation is there that I am going to tell you. So what the relation is there? Relationship between Kp and Kc. relationship between Kp and Kc. Kp and Kc. So how can you establish the relationship between Kp and Kc? Because Kp and Kc are not always equal. Okay, for all the reactions, it's not going to be equal. At the certain condition, it can be equal also. But 99% cases, it is not going to equal. So what you see, the same equation I'm writing, A mole of A plus B mole of B, it is going to give C mole of C plus D mole of D. So here you see what we can write. If you are writing that is Kc for this one, Kc. Can you please tell me what would be the Kc expression?
Concentration of C to the power of C multiplied by concentration of D to the power of D divided by concentration of A to the power of A and times concentration of B to the power of B.
Thank you. And similarly, can you tell me that is Kp expression?
Kp will be P pressure of C to the power of C times pressure of D to the power of D divided by pressure of A to the power of A plus pressure of B to the power of B.
Thank you. Thank you very much. Okay, this is there. So this is the equation number 2. Do you know from ideal gas equation? Have you heard about the ideal gas equation?
PV equals nRT.
Ideal gas equation. So when you are talking about ideal gas equation, PV is equal to nRT. Okay. So if you are writing P is equal to, so it is going to N by V. It is going to RT, yes or no?
Yeah.
Okay. So if you see here, what we are going to see, okay. So P we can write that is P. N by V. N by V means what? Mole per liter.
Molar. Yeah.
So molar, or you can write molarity. Just now I told you in the some page back here, you see, if it is there. Where is see, molar concentration means mole per liter or molarity or active mass, and it is all together written in the square bracket. Yes or no?
Yes.
So I am writing a square bracket. So we can write that is P, that is RT. Yes, na? For gas A. For gas A. So for gas A, what we can write? PA is equal to, in the bracket, it is going to be ART, right? If you are going PB, so in the bracket, it is going to be BRT. Here you see, if you are going PC, so it is going to be CRT. And here, if you are talking about PD, so it is going to be DRT. Getting this?
Yeah.
Okay. So A, B, C, D are there. So these all the values, whatever we value you got this one, can we put these value in equation 2? Put these values in equation 2. Values in equation 2. Okay. So equation 2, if you are putting this all the value in equation number 2, so that is Kp, what you are going to get here, Kp value. So Pc power C. So C value can be write, that is where is this value you can write this value. So PC value can be write. So I am writing C, here will be that is total power is C is there. So, okay. So I am writing C and then I am writing RT power C. Can you be able to write this one? Because PC whole power C is there. It means it is going to be this one, active mass power C and RT power C. Yes or no?
Yes.
Then next one, it is going to be that D power D and RT power D. Yes.
Yep.
Divided by, if you are going, that is A power A and RT power going to be A. And here is B power B and RT power also going to be B. Similar term we have to take in the same side. So that is C power, I am writing that is C power C, D power D. Here what is there? Another thing. A power A. This is going to be A power A, going to be B power B, and here is this is what is there here. RT. RT. It is going to be C plus D. RT. And here is what are there again. RT is there. A plus B. Yes or no?
Yes.
Okay, now solve. They are the A, B, C, and D. They are what? They are the coefficient. Yes or no?
Mm-hmm.
They are coefficient. Acha, you tell me here one term I use. What are the term? C power C, D power D, A power A, B power B. This is equal to what?
Sorry, I didn't understand. So C power C, this is just the KC.
Kc. So I am writing Kp is equal to, it is going to be Kc. Yes.
Yeah.
And here see the RT is the base is same. So RT is base is same. So it is going to be C plus D in one bracket minus, if you are putting the numerator, it is going to be A plus B. Yes or no?
Yes.
So what we can write, that is Kp is equal to, you can write that is Kc and RT power delta Ng. Okay, this is what the relation Kp upon Kc, RT power delta Ng. Come now, so we have to define that is del Ng. What is del
Mm-hmm.
Ng? Delta Ng means number of, they are saying gaseous product, number of gaseous product, okay, or you can say moles of gaseous product minus number of gaseous reactant, number of gaseous reactant, gaseous reactant. So delta Ng means short term, you can write NGP, number of GP
Mm-hmm.
minus number of GR. Yes, this is it clear?
Okay. Yeah.
So can you please, if you want to write that, can you make a note of it, please?
Yes. I was just writing it down.
Hmm.
Okay, I noted it down.
Done?
Yeah.
Okay, thank you. So let's try to solve some of the expression based problem on it. So what are the expression based problem if you talk about question is there. The right and expression, they are saying right and expression between Kp and Kc for following.
Mm-hmm.
So 2 3 equation I'm giving you. N2 gas plus 3H2 gas giving rise to NH3 gas. This is there. Another equation, if you can write this one another. So this is the A number question, B number also you can write this one. H2 gas plus I2 gas, it is giving to be 2HI gas. So they are saying that is write the expression between Kp and Kc. So
Mm-hmm.
you know, according to equation, if you are going according to equation, so if you are talking about according to equation, so Kp is equal to, it is their equation is Kc RT power delta Ng. Okay. So for this one expression Kp and Kc, what can be the difference? R is the constant, T is the constant, Kp and Kc the value will be as it is. So delta Ng
Mm-hmm.
will determine delta Ng. So delta Ng means I told you number of Gp minus gaseous product minus number of Gr gaseous
GR.
reactant. So
Yes.
gaseous product, how many mole are there? So it is being formed 2 mole. So here is 2
Mm-hmm.
minus reactant 1 mole is there N2 and 3 mole
Plus
H2.
3.
So it is giving 2 minus 4. 2 minus 4, it is going to be what? Minus 2. Yes or no?
Mm-hmm. Yes.
So Kp is equal to Kc RT power minus 2. This is the one
Mm-hmm.
expression. Okay. We have to check the option, or you can write here is the, we are having what? Wait. It is, we can write that is Kp is equal to Kc upon RT power 2. Yes, yeah.
Yeah.
Similarly, you tell me for the B equation. Please try to solve for the B.
So B will be, so case P is equal to Kc RT over delta Ng, and delta Ng is equal to number of gaseous products, which is 2, minus the sum of the gaseous reactants, which is also 2, so it will be 0. And since anything to the power of 0 is 1, this is just going to be Kp is equal to Kc RT. Oh, sorry, Kc. It's just equal to Kc.
So Kp is equal to Kc. So thank you very much. Kp, so means Kc is equal to Kp, or you can say that is Kp is equal to Kc. Yes, no?
Yes.
Okay, so you got to know the expression. Let's try to solve the problem. Okay. So how can you be able to solve? See the question. At, they are talking about at 500 Kelvin. Kp is 2.4 into 10 power minus 2 atm. Okay, they are saying for the reaction. I don't know the, here in the question they have given the unit, but 99% cases you are not going to get the unit. Okay, this question I have selected from there only. Some other book I got IB book. This question is from the IB. Okay, so that is for the reaction they are saying 2NOCl is there. 2NOCl, this is the gas. It is splitting into, that is 2NO gas, and plus it is going to give Cl2 gas. Okay, they are saying calculate Kc at same temperature, if R is equal to, they have given 0.0821. Option I am writing A number option 5.8. No, it is not that. 8.8 is there. 8.8 into 10 power minus 4. B number they are talking about 6.8 into 10 power minus 4. C number 5.84 into 10 power minus 4, and D number none. Sorry, can you please try this?
So I got option C, 5.84 times 10 to the negative 4.
Oh my God, your calculation is very fast here. Calculation. Always, so your calculation is too fast. So what I am doing, because your calculation is fast now, you will be able. I have the 1,000 of the problem based on it. I have selected from so many books. So this, okay, you will be able to solve. There is nothing problem there. So better to teach you the numerical calculation. Better to teach the only the calculation portion, how to calculate. Already concept you got to know. So I am telling you the another concept. In spite of teaching the calculation portion, I am telling you some other concept. So here you go. This. So question, equilibrium constant. They are talking about equilibrium constant for different type of reaction. Constant for different type of reaction. Different types of reaction. So different types of reaction means type 1. If equation is reverse, they are saying if equation is reversed. If you are reversing the equation, suppose I am having A plus B, it is this one, C plus D. Okay, so they are saying to you calculate for the reverse reaction. How to calculate? If you are reversing this equation, reversing means that is C plus D is splitting into A plus B. So how can you solve this one? How? So they are saying new equilibrium constant, new equilibrium constant constant Kc dash is equal to 1 upon Kc. So if you are reversing the equation, so that is, it is also the equilibrium constant is going to be the reverse only. Okay, means inversely proportional. Getting my point? Because here for this reaction, if you are writing the Kc, for this reaction you are going to write Kc dash. So you are reversing this one, so it will go in the reciprocal. Yes, yeah, no?
Yes.
Okay.
Yes.
So let me try to find out the one problem. You wait a moment. Wait a moment. Yeah, I got the problem. Let's see. They are saying I'm giving you one problem based on it, na? So question they are saying Kc for N2 plus 3H2, they all are the gas as usual. 2NH3 is 2 into 10 power minus 2. Okay, then find equilibrium, then find Kc. They are saying then find Kc dash for, they are reversing this one 2NH3, reversing this one N2 plus 3H2. Okay, so can you solve this one?
So Kc prime.
Option they have given
Kc
50. A number is 50, B number is 100, C number is 150, D number is 200.
So this is going to be 1 divided by 0.02. So this is the 50.
50, na? So
Yeah.
this is our required answer. You will be able to solve this type of problem?
Yeah.
Okay. So let's try to go with the another one. What the another one if you are talking about? So if the reaction is divided by 2, if reaction is divided by 2, so if you are dividing the by 2, so whatever the coefficient is there, that going to be power. Okay, so in all the cases, that is the Kc dash is equal to Kc power n. It goes to again power n. That's very simple. For each cases divided by 2 or divided by 3 or divided by 3 also if you are doing. So what will be there here? So in case of divided by 2, so Kc, okay, Kc dash is equal to Kc power 1 by 2.
Yeah.
Okay, divided by 3. So Kc dash is equal to Kc power 1 by 3. Can you understand this? Yes, na?
Yeah. Yes.
Because coefficient is what? It is going to be 1 by 2. 1 by 2. The coefficient we write in the power now. So it is going to be get the power. That's very simple. Acha. So this 1 by 2. So they are saying Kc is equal to Kc dash is equal to. Can we write root of Kc?
Yes.
Okay. So this is there. Another things, if any other things are there, no. Acha, divided by, if you are talking about another things, see the, if multiplied by 2, if multiplied by 2, so what will they multiply by 2 means the coefficient directly coming in front of 2, so it is going to be get the power directly. Yes, na? So if you are writing the Kc dash is equal to what? That is, it is Kc square. Yes.
Yes.
Here if you are multiplying by n, you can multiply by n also, multiplied by any value, suppose 3. So what the Kc is equal to, Kc dash is equal to Kc power, it is going to be 3. Yes, is it correct?
Yes.
Is it correct? Yes. Good. So if you can make a note of it, so we can go give another problem on it.
Yep. Noted.
Okay. Sorry, what is the timing in your area? What the timing right now? What the time is going on there?
Right now it is 5:30.
5:30. Okay, 5:30 means it is here in India. It is going to get the 3. So there is 5:30.
Yeah.
Okay, it's evening. Do you have any alternative time than this one?
Yes, actually, I'm actually okay. So yesterday I got a message saying that you would like to do the class between 2 to 4:30, and the same time on Saturday works for me.
Saturday I am free.
Yes, I can do same time on Saturday. I would have done it yesterday, but yesterday actually I had plans with my family because I don't usually have classes on Saturday, but we can change it to Saturday now.
Mhm. So in spite of studying Sunday, you can study on Saturday, yes?
Yeah,
Okay. So Saturday we can go for 2:30 to 3:30. Is it okay?
30 to 3. Uh,
Is it possible?
is 2 to 3 possible?
No, no,
Is 2 to 3
two.
possible?
Actually, I'm
Because
getting free
2:30
on
to,
two.
okay.
I'm getting
Oh,
free.
cool.
I'm getting free on two. But while reaching back to home, it will be 2:10 like that.
Okay,
2:15.
yeah, so
So
2:30 is fine then.
2:30. Yeah, yeah. So 2:30 to 3:30 on Saturday. Yes, no?
Yeah.
Okay, please make a note of it. Please be available during this time so we
Yeah.
can study. Okay, now, so this our problem is solved. Here is the product of equilibrium. If you are talking about, suppose two equilibrium reactions are there. So two equilibrium, so Kc final. Yeah, you can write Kc product. So what will be the Kc product? It can be that is Kc1 multiplied by Kc2. These are there.
Mhm.
Okay, so on the basis of these, we need to solve the meaning of the problem. Okay, so how can we be able to solve the problem? Can we give the problem, or you want to do the next day? That also you can let me. Can we do?
Hello. Yes. So
If you are having the next class immediately, wait.
I'm sorry, so you cut off for a second.
Okay, so I'm writing the one problem. I'm taking one
Okay.
problem.
Yeah.
Okay, so 5 minutes I will take little bit more. They are
Mhm.
saying 2NO plus O2 giving 2NO2, right? 2NO2. And Kp they are saying, and Kp is equal to what? 100. Kp is 100. So they are saying a number. Calculate Kp if equation divided by 2. Equation divided by 2. Can you calculate this? Equation divided by 2.
If equation is divided by 2, then Kp will also be divided by 2, right?
So how much will be there? Keep
50.
50. No, no.
Wait, if equation is divided by 2, oh, this will be square rooted, so it will be 10.
10. Thank you very much. So Kp dash is equal to 100. This will be our answer. Okay. Suppose I am taking another thing. If equation is multiplied by 2, they are saying if uh, equation multiplied by 2, if equation multiplied by 2, then
100 squared, which is 10,000.
that is 10,000. Okay. Thank you very much. So this is Kp dash. Now, C number they are saying. Hmm. For reverse reaction, if equation is reverse,
If equation is reversed, then 0.01.
so 0.0. Okay, last portion they are saying reversed, then divide by 3, then divide by 3.
Then
Firstly
reverse and
reverse,
divided
then
by 3.
divide by 3.
So
So
this is going to be cube root of
hmm,
0.01. So that is 0.215.
0.215. Oh my god. See, calculation is extremely too nice. You know, I am very much fond of your calculation. I admire your
Thank you.
calculation speed because these are the multiple concept is going on. The same way you are fitting the concept and you are doing the calculation. That is very good things. Because the
Mhm.
other student I am dealing 1 2 student also IB student, 2 more students are there.
Mhm.
But their calculation speed is very much. I am doing calculation for them. So here, one
No,
is
my
the
parents made me do a lot of mental maths
ah,
earlier.
that is why you are doing that. That's much better now, because here in the evaluation process also, this one oral, whatever the oral evaluation is there, these things will help you a lot. How
Yeah.
how the your mind is feeding your concept. That is what proportional to your evaluation and performance, the oral or the some other type of the tests. Yes,
Mhm.
you know. So can we finish today and we'll study in the next class?
Sure. Thank you, sir.
Okay. Okay. Bye. Take care.
Thank you.